Let's graph the following function here. So in taking a look at this example and expecting to graph it, you should always take a look at the equation, see what's going on. A lot of times just glancing at the type of equation you have is going to give you some good information about the graph. First thing I am noticing is the absolute value bars that we have here. So absolute value graphs, they look like V's. A positive absolute value graph is a V opening upwards. A negative absolute value graph is just shooting downwards here. So just by looking at the bars, I know this is the shape I'm working with. Looking at the front of the equation will tell you if it's positive or negative. Ours is positive. There is no negative sign here in front. So we do know that we're looking at the positive absolute value graph. Okay? So we do at least know the shape and the direction our graph is going in. Now right here underneath it, I have the vertex form of this graph here, so it's standard form here, which means if you have a number here in front like the 1/2, the 1/2 represents A. A is a compression or a stretch. What it does is essentially, it's going to make your graph either fatter or it's going to make it skinnier, right? It's going to compress it in or it's going to stretch it out is what that number tends to do. If this number is bigger than 1, you are looking at a compression where it looks skinnier. If this number is less than 1, you are looking at a stretch where it looks wider, it looks fatter. The next most important thing to pay attention to is HK. H on the inside of your absolute value bars refers to a horizontal stretch. It's a movement left or right on your graph, where K is a vertical shift up or down. Now, I always say when it comes to these style of graphs, you always want to start by plotting HK. Now, whenever we plot HK, right, HK is going to be our first point here. Now, because the way that this formula here is set up, it says x minus h. Whenever we grab h, we want to pull just the h. Okay, so for us, what that tells us here, because we have an x plus 3, what we are going to pull from that is a minus 3. It's kind of the whole concept here. We have an x plus 3 here on the inside. If we were to set this equal to 0 and actually solve for what x is, x would actually be a negative 3. Okay? Or in your head, whatever numbers here on the inside of the parentheses, inside of the absolute value bars, pull the number, pull the opposite sign of what's in front. If this says plus, put a minus. If this says minus, put a plus. Okay? So h is a negative 3. K is just a 6. K is just regular OK. This is plus 6. Put down a positive 6. What that tells us, our starting point here, the first point we're going to plot is going to be a negative 3, a positive 6. And we know from this point our graph is going to be going upwards in this direction here. So we almost know exactly what our graph looks like. Now when it comes to absolute value graphs, 3 points is good enough. Your starting point here, 1 point on either end. Now there's a couple of different ways that you can graph this problem from this point here. I always say let's go ahead and just use an XY table. Let's go old school, plug in points to figure out the rest. Since my HK here is a negative 3, 6, I'm going to pick a negative 2 for my X here. So I see what my graph is doing right here, right directly next to my starting point. Which means I'm going to go ahead and I am going to plug in a negative 2 for x and simplify this. All right, if I plug in a negative 2 for x and simplify, this is going to give me my y value for this point. So negative 2 plus 3 is just a 1, which makes this 1/2 times 1 plus 6, since the absolute value of 1 is just 1. So this is really just 1/2 plus a 6. Which is technically just a 6.5. What that tells me is when I plugged in negative 2, I got a 6.5 as my y. So just a tiny bit up here. Negative 2, 6.5. Now the great thing about absolute value graphs is that these are symmetrical across HK here, which means from this starting point, if this point here is 1.5 up, on the other side, I can do the same movement. I can go out 1 and up a half, the same amount here. All right, so from your vertex, essentially, out 1, up 1/2 by the math that we just figured out. All absolute value graphs are symmetrical, so as soon as you find a point on the right-hand side, you can mirror it on the left-hand side over here. Connect your dots, and that is what your graph looks like.